认识的现在在药商国际频道的，我让
报告，
我在这明显就是因为，哎，还有他可以啊。好，可以。
给他休息时间15分钟。
对，把。
我的电脑关机哦。搞什么？我没有关机啊。
我们在这准时开始啊，我们在10分钟。
为什么？
你们都 OK 了吗？这台可以，我们测试一下。这个下面都有不放的。
直接测试。
示范一下你。
你现在来讲，
你是用专属的程式。
你的公版就是不知道，
大家用这个。
公版是程式。
我先把我报告过去。
Morning. Before this conversation, I will introduce today's jurors. I'm chairman and come from the military academy. The first juror is Shi Huaqiang from the National Taiwan Normal University. The second from the National Taiwan Normal University. Zhang Qinghao from the Danjiang University. And Wang Xunyu from the Zhongshan University. Next, briefly introduce your team.
Okay, so good morning. I'm the team from Relativity, and I'm the captain for this team. And as for my member, and my name is Li Yongzhang. And as for my members, here is Luo Dazhao, Wang Ruichen, Zheng Diyang, and Chen Boyu.
Good morning. We're Team Miracle from CK High School, and I am the captain, Lin Junyi. He is Zhou Yingxiang. He is Zhang Renzhe. He is Li Yijing. He is Huang Yuchen. Thank you.
Thank you. We are officers, and I'm the captain. My name is Chen Mingyu, and my member is Chen Boyu and Wu Pingruan. Thank you.
Okay, thank you. First, opponent will be challenged as a reporter from the department. Have 1 minute.
Number 10, meditate here.
Okay. Judge.
Okay, so we accept this
Okay.
challenge.
Accept.
这个是写上对，是写那个选手。
下面这个是选手的。
Okay, time's up. Now presentation of a reporter.
Okay, hello everyone. I'm today's reporter Tony Chen, and I come from Team Relativity. And today I'm going to talk about the question number 10, magnetic gear. And the proper statement of magnetic gear is when you take several identical fidget spinners and place them side by side on the pan, and when you rotate one of them, others will rotate only due to the magnetic field. You need to investigate and explain this phenomenon. And here's my main focus. First is the maximum speed difference for accelerating or decelerating about spinner. And second is the energy transfer rate between the spinner. And third is the maximum driving torque between the spinner. So first part is the gear properties. And this observation, it shows it can be observed in many exhibit two characteristics, torque and the transmission. So at the first part of observation, I do the transmission observe, and at this part I do the magnetic arrangement observe. And at least you can see when it's in a proportion, it will more stable, while the attraction is easy to feel worried. So to further confirm this, I try the three spinners, and when I drive the non-stable pair or a stable pair in the attraction mode, it won't rotate, but in the proportion part, it will. So based on observation, I give some analysis of this thing. Because the magnet is not continuous, so the stable situation is limited to 3 points. So this makes this phenomenon less stable. And next is the proportion part. And because the magnet is not continuous, so you have a greater distance to let it in the stable conditions. So I choose the proportion as my arrangement mode of the magnet. So next part I observe is the speed difference. And when the speed difference is in a certain range, it will feel rolling. But when the speed difference is too large, it will have a free rolling. So the final part I observe is the energy transfer. Our magnetic gear also experiences energy transfer and energy loss. It will continue to lose its energy until it stops. So next is second part about distance. And first, I define when a circle traced by the fidget spinner is tangent to each other, I define it as 0 centimeters. Any closer distance, I define it as negative values. And farther distance, I define it as positive value. So after I define the distance, this is my actual setup about distance. And first, I found the minimum distance that two gears can affect each other. And first, I found when it's negative 0.25 centimeters, it's a minimum distance can affect each other. Any closer distance, you will attract each other and cannot be a magnetic gear. So I first use a motor to let it spin continually, and I found that instability in the transmission phenomenon is began at 3 centimeters. So I used hand to let rotation speed slowly, and I found that the 4.5 centimeter is the maximum distance they can infect each other. And on the farther distance, you won't rotate. So based on the experiment, I gave some analysis of this phenomenon. And when the two magnets is too close, the repulsion was smaller than attraction, so the two magnets will attract each other and stick together. And when it is too far, the magnetic field will be too weak, and it cannot provide enough torque, so it cannot let it rotate. So next part is the maximum driving torque part. And to determine this is to determine when the boundary condition happen in the stepping phenomenon. And the stepping phenomenon is when the external torque is bigger than the maximum driving torque, it will have a free warning phenomenon. So what I need to do is I need to find out the boundary condition of this stepping phenomenon. So because the torque is caused by a magnet force, so I first consider a magnet as a tangential magnet to calculate purpose. And after I consider the magnesium as a tangential magnet, I can get a magnetic field in equation 1. And after I put my experiment data in this and I do calculate, I can get a magnetic field equation like the blue one. And because we have 3 magnets in a fidget spinner, so we need to sum them up so we can get equation 2. And after I put this into decimals, I can get a magnetic field and a to-distance relationship. So because we have a magnetic field in hand, so we can calculate the torque of a driving gear, and the torque of a driving gear can be expressed as this equation. And where the J is the surface tension, A equals to M, and M is the magnetic radiation intensity. And because my theory distance is from the center of the fidget spinner to the magnet, so the distance from negative 0.25 to 4.5 centimeters in the theory is 4.25 to 10 centimeters, and we not consider the 5.25 to 5.5 centimeter. And here's my actual setup about torque. And what I do is I put a force sensor and make it vertical to the gears, and I rotate another gears and calculate the maximum driving torque. And one variable I do is I change the distance between the two magnets, and I can calculate the different distance and the maximum driving torque relationship. So I use a linear graphical analysis and Excel to analyze this data for experiment about torque. And after I do an experiment, I can get data like this. And after I put this into a C++ to calculate the R square, I can get R square is equal to 0.962. And next part is the fourth part about energy transfer. And what I do in the experiment setup is I rotate one of them and I calculate the energy transfer between the two spinners. So because the energy in the future spinner is about rotation energy, so it can be expressed as 1 divided 2 times I omega squared. So what I need to do is I only need to calculate the rotation speed change, and I can calculate energy transfer rate. And so first I need to calculate the rotation inertia. So at this part, I use this equipment to determine my rotation inertia. And what I do is I use the weight to let it have a stable force to let it spin. And I calculate the time through the photoelectric gas, so I can get a rotation inertia. And after this equation, I can get a rotation inertia is equal to m times 3 times r squared t squared divided by 2s. And I put this data from experiment into this equation, I can get a rotation inertia like this. So next way I to determine the rotation inertia is I use the weight. And I measure a bearing weight and magnet weight, and I use I equals to mr squared to determine this rotation inertia. And I can get rotation inertia like this. And because we have a two-way to determine the rotation inertia, so we can get average is 0.000536 kilograms per meter squared. And because we have the rotation inertia, so we can finally calculate energy transfer. And what I do is calculate energy velocity change. And after I use checker to check the motion, I can get this data, and I can calculate energy transfer rate, and I got averages about 75%. So next is the final part about speed difference. And first is the maximum speed difference for acceleration. And I tried 2 and 3 and 4 future spinners and to determine the numbers of spinners and the maximum speed difference for acceleration relationship. So at first, I define what is transmission and what is not transmission. And I define when it's free rolling, it's no transmission. But when it's having a gear motion one time, I define it as transmission. So in this experiment, I use checker and Excel to analyze my data. And first I do in this experiment is I do a 2-gear max speed difference for acceleration. And what I do is I calculate the maximum speed difference from previous driving instance. And at this page, you can find it around the 4 seconds. And after I do a 2-spinner, I do a 3-spinner, and I focus on the first 2 to determine when the transmission phenomena happen. And this page is happened around 1.2. And after I do a 3-spinner experiment, I do a 4-spinner experiment. And because it's likely to 3-spinner, so I also focus on the first 2 to determine when the transmission phenomena happen. And at this page, you can see more clearly the spinner, the maximum speed difference for acceleration is happened around 1.2 seconds. So I collect all data in this chart, so I can get when the maximum speed difference in the 2 future spinner and 3 and 4 future spinner is almost the same. So I think this only have a relationship between the future spinner itself and the future spinner beside itself. So I do more experiments, I can get more data, and I get total averages around 369 degrees per second. So here's the analysis based on the experiment. And when the speed difference is in a certain range, it will generate a driving force and make it rotate. But when it's been too fast, it will generate a repulsive force and push it away, so it will happen free rolling. So let's write the final part about maximum speed difference for deceleration, and I use energy to consider this. And when the magnetic gear is in this state, you have a smallest magnetic potential energy. And the next part, you have the biggest magnetic potential energy. And after I calculate this data into these 2 equations, I can get a magnetic potential energy difference like this. So in my experiments, what I do is I'm fixing the one fidget spinners and I'm rotating another fidget spinners like this. And I use my phone to record its motion, and I use tracker to analyze this motion. And after I record it and use tracker to analyze this motion, I can get a maximum speed for this rating is around 770 degrees per second. So, based on the experiment, I get some analysis at this. And because when rotation energy is smaller than magnetic potential energy, it will generate an angular effect. And the data I got, the angular velocity is the minimum velocity that it can let it happen a free rolling. So when I compare the rotation energy I get from the experiment and the theory I get the magnetic potential energy, I can find that the rotation energy is a little bigger than the magnetic potential energy. So I think it's right. So here's the final part about conclusion. The transmission distance is limited to a distance of negative 0.25 to 4.5 centimeters between the two magnets, and the theory is around 4.25 to 10 centimeters. And second is when the distance between the two magnets is 0 centimeters, the fidget spinner will produce the maximum torque. And the final is the third is when the maximum speed difference for the accelerating is around 360 degrees per second, and for decelerating is around 770 degrees per second. And I think it's already a relationship between the gear itself and gear beside itself. Okay, that's my presentation. Thanks for watching.
Okay, now question of the opponent to reporter and answer of the reporter. 2 minutes.
First question is, when you are doing the experiment, have you used another port to in the sample to try to repeal them?
I have do this in my observation. I try to make that arrangement, and I try reporting and attraction. So I have to do this.
Okay. And have you tried to put your magnet on the top of the gear?
At least pretension, I don't do that because when you put the magnet on the top of the magnet force between the two well smaller than you just put it outside.
And have you tried to do more experiments such as to increase the amount of the gear or other variable to change your experiment?
I have to do 5 experiments, and when you say the fidget spinners numbers, and I have to do that in my experiment. Yes, and I have tried not only 2 fidget spinners, and I tried more.
Also, you mean you have only tried to change the amount of the spinner, right?
Not only this is a
one
parameter.
experiment.
Yes, this is one parameter of my experiment, but it's not all the parameter of my experiment.
And when you are doing the experiment and you are recording, are you using slow mo to record your experiment and do the check?
Now preparation of the opponent.
不要用延伸进去，用那个，你用延伸，不要用延伸。对，你用延伸。
Hands up. The opponent makes a phone and the discussion between the reporter and the opponent. 14 minutes.
And in this problem, we'll be able to focus on what variable will affect the angular velocity and how does the magnetic field work to cause this phenomenon. And for the process cost, the process explain their problem clearly and also have to that variable to prove their theory is correct. And the process not mention which tools and not changing the pace of the magnets and could do more experiments such as the same variable can do more times to have an average and try to put the magnets on the top of the gear because it maybe have both to have some difference on that. And for the discussion results, for the phenomenon, first is the energy transfer, and the second is what distance will put two spinner attract to each other and could rotate. And for the second one, I think it will they also make the sample to try to repel them and further rotate. And third is if the speed difference is to be another spinner will rotate. For the experiment, they have changed the distance between each the gears and also found the speed is different. For the theory is they have used their experiment and their theory to associate the what they have in between them. Okay, and the suggestion is they could try to put the magnets on the gear or do other variables on this experiment to and it can prove if we put all the experiment on another variables, we can still prove it is true of the theory. Thank you. Okay, and we are going to you didn't put the magnets on the top of the gear because the angular velocity will not be obviously right.
Can you repeat?
In my question is you didn't put the magnets on the top of each gear is because it will not obviously to let you watch this phenomenon, right?
No, I put what I put the magnet on this side is because when you put a magnet on the top of the spinners, the magnetic force and affect to each other was smaller than you put that like this part. So it will let less stable, and because my current behind this presentation is, and I need to make this more stable so I can do the experiment well. So I try the magnetic and this side of the fish spinner.
Although you mean each magnetic lines of the force intensive level are different, so it could let it rotate obviously.
If you try the magnet, put it on top, and it will because you will have the magnetic force smaller. So I don't know what you mean when you can see the rotation obviously.
Okay, and have you do more gears in this instrument?
Yes, I have to do that. Like, what is this? This side, I'll try many. Here, I have tried many gear spinner for placement. Like I tried 2 and 3 and 4 times to measure and make the difference like between the spinner numbers of this relationship.
And continue to my last project in my aspect is when you are recording, are you using the slow mode to record the phenomenon and calculate?
And yes, and because when you rotate it and you try to analyze this, you will find the rotation speed and it's very fast. So when you use the normal to record it, you cannot see it clearly. So I use the slow motion to record this motion, and the most good way to do this you can see, because when you see this rotation speed is very fast, so it won't like the video is so slow. So this is probably why I use slow motion of the experiment.
Did you find any pattern and predict what will happen when there are 5 or 6 or more spinners?
Sorry, what do you mean?
Did you find any pattern to prove if we have 5, 6 or more spinners?
Do you mean in the next experiment or what experiment? Because I have 5 experiments.
I mean, what spinner?
Yes, and what spinner do you mean in this experiment? Oh, okay. Because if you say in this experiment, I think the mass difference is the same if you put this more. And if you say the energy transfer, I think is 75%. Yes.
And when you are analyzing, did you count the original frames to your video? Because you check it on the slow mode.
Yes. So,
did you count your data back to the original time?
yes, sure. Because in the tracker I can change I can change this. So I have changed it into the true speed of the frame.
Okay, and when you are changing the port of the magnets, are you change all of the port on the magnet or just one or two?
No, and I should say this. And at the observation, I changed all the arrangement of the magnet. I changed it all into the proportional or is the traction. So yes, we are very unique.
Okay. So you didn't do. We have only changed one or two magnets on a gear, right?
No, but I have tried, but because when you only change one or two magnet on this, it will more not stable because if you turn to the repulsion part, it will push away and it will let the suddenly attraction or repulsion bigger, so you won't have the stable part like why I don't use the traction. Because the traction in this part is have the suddenly acceleration or sudden repulsion. So yes, I don't think that if you only change one or two is pretty difficult way.
And would a spinner will oscillate on the y-axis?
Wait,
Will the spinner will oscillate on y-axis?
why? Oh, you mean why?
It will oscillate like this.
So you mean if the spin is rotated
Yeah.
like this?
Yes.
In my experience, I didn't consider it because what I get a future spinner is
It's recorded on the top.
no, because the future spinner is stable, so you won't have the y-axis.
So do you have the trestle to? Do you have put your spinner on the trestle?
Wait. What do you mean transfer?
The trestle is such like this. You can put the either on this.
Do you mean I put item on this is to make
No,
sure
I mean you put your spinner on something to make it higher.
hold on. This part. Wait. Let me find it. And my experience it have like this. And because when I use the motor, this one, if the center is cannot spin, so I need to put a more spinner under it so it can spin in a set height. And because if your spin is not in a set height, the magnetic force is not easy to consider that.
But so the under one will now work in this experiment. In this type of experiment.
Yeah, it
You
does.
have worked the top one.
Yes, yes. The under one is just to make it can rotate at the same
So
time.
when it is rotating, the magnet field is affecting the gear, and it may be able to talk about the oscillate on y-axis.
No, it is doing in this experiment.
Yes.
It have for in every direction, right? But because only thing want to consider is the torque it can make on this. Because when the spin is not only this axis, it won't do the real thing in this because this is magnet. You can control it.
Your main opinion is it may be able to oscillate on y-axis, and when it is rotating, it will be influenced by the magnetic field, and the gear will be oscillate on y-axis, and one of the gear may be able to touch the under one gear.
No, it won't because in my experiment I control the center of two field spinner touch. So in the touch, it's very stable, so it won't happen if mean y-axis swing like this. It won't. It will just stay by that.
Can you stop? The approval summarization of the discussion. 1 minute.
Okay. In the discussion just now, they have used another spinner to be a cancel, and the space on each gear may be able not to be larger. And in my opinion, I think the gear may be able to influence it by the magnetic field, and it will oscillate on y-axis. Then the gear will touch the other one gear. But in their experiment, they found it will not happen. But if I go to not near, the two gears is not closely, and the magnetic is on the side. Okay, thank you.
Council, now question of a reviewer to reporter and approval and answer the question. 3 minutes.
All right, I would like to ask the reporter. First, you mentioned that you didn't put a magnetic on the top because the force is small. But what do you mean small here? Because I didn't see any kind of experiment.
I mean, the smaller is relation to this, and when I put this to the sample is have a same direction like this. So it will, because if you put a central magnet at least, it will have a bigger or you put the two cylinder, put it up and closer to mirror distance.
I see. Thank you. And for the component, in your first question, you asked the arrangement is that where you put the magnetic.
Yeah.
But what do you think that about the different arrangement of the magnetic will affect the angular velocity?
In my opinion, I think if we control the distance and the amount of the gear, the magnetic lines intensive level will be changed on the top or on the side.
All right, thank you. And for the reporter, you mentioned the energy transformation in your presentation.
Yes.
And can your theory predict the percentage of energy transformation?
My theory cannot quantitative to predict this thing, but I have do some analysis of this because the energy do from the angular velocity transfer. So, and I only do is calculate any chance.
Thank you, I see. And another question, can you go to page 46? And can you explain 46?
Doing this in
Yes, can you explain the oscillation?
And also is first I use my hand to driving this first spinner and I make it rotate. And so I use the tracker. I use the phone to record in motion like this. This is whole in motion, and I just cut it into three video so you can see this and this relationship.
And last question: how do you make sure that the direction of the magnetic movement is in the radial direction?
No, because in another direction it will cancel by this setup, so I don't consider this.
All right.
Time's up. Questions? Let's start. The reviewer next for 4 minutes.
Hello everyone, I'm the reviewer for number 10 magnetic gear. First is the review of the report. Their presentation, I think, is very easy to understand, and they have clear physics ideas, and they discuss, but they didn't mention the limits of the theory. And for experiment and parameters, they did important parameters, but they didn't show the magnetic strength and direction. And for data analysis, they fit the theory, but they didn't do the deviation. And for the opponent, they have their presenting styles, but it's not comprehensive. And their short question is short and apt, but the question is imprecise. And for the discussion part, they have pointed out some crucial points, but there's too much time wasted and too focus on problem statement. And here's the key discussions. For the opponent thinks that the magnetic should place on the top, but the reporter thinks placing by side is more stable. And in our point of view, we think that the magnetic position is a very important parameter. And another is that opponent thinks that oscillating on the vertical axis is important, but the reporter thinks the fidget spinner is stable, so the effect is negligible. And for our point of view, the oscillation in the vertical axis affects the distance between the magnetics, so does affect the theoretical prediction. And our question is that what do you mean by the force is smaller when the magnetic is placed on the top? And the reporter, they have fuzzy terminology and didn't explain their data. And our another question is that what do you think magnet configuration affect the angular velocity? And the reporter didn't give us a very clear answer, and the opponent thinks the distance will be different. The last and the question is that another is that can your theory predict the energy transfers? And the reporter says no. And that's it. Thank you.
Okay, so here's a concurrent remark of our reporter. And for the power statement is you take several identical fidget spinners and place them side by side on head, and you rotate them, that will rotate only due to the magnetic field, and you need to investigate and explain this phenomena. And a report, I use the magnetic field to analyze the torque, and I do experimental energy transferring. I got energy transfer in this experiment about 700%. And I use the rotation energy and rotation. I use the rotation inertia to determine what I my rotation energy in this experiment. And my experience setup is I use the identical fidget spinners, and I use several identical magnets on the fidget spinners, and I use a motor to let us spin continually. And the parameters I do very parameters, and like first is the distance, and second is the traction force, and the thing is the magnetic force, and the fourth level is the speed and the amount of the speed numbers. So and the detection part, and one asked me, did you put the magnet on the top of the fidget spinners? And I think you would let this less stable, and because the magnetic field will be smaller. And he asked, do you do several experiments? And I said, yes, I have to do this in the experiment. And I'm using slow motion camera, and I use it to record motion. And I find further when see more experience, yes, I find it's about 75%. And then this part, I check the firm, and in the tracker, I use check to like the firm is speed. Yes, it's right. And with the spinner change in y-axis, no, because when it's stable, the wax force will cancel by the setup. So next part is do you put a magnet on different heights and using static current?
That's
all.
Now the question of the jury.
About the report, I don't want this, and your conclusion say you have the energy loss about 75%, right?
No, I mean the energy transfer rate.
The transfer rate 75%. It's only for the two spin, right? Two spinner, right?
No, yes, between the two spinners, and because in my assurance I tried the 2 and 3 and 4 previous spinners, and I found it's about affected to two spinners, right? So, and I consider is one magnet, one previous spinner transfer to another spinner will have the transfer rate about 75%. So the second and third previous spinner, you just reconsider it, so it's only 35% too.
You also have 75%. Even you have three third spinner, right? You mentioned this one.
In different, I predict this is about, I think it will happen in the same energy transfer rate because and when I do experiment, I found every figure spinner is the same and the drawing down at least is happen two and when you try it more, it has copy the two happens and product is more. So I think if you put 3, it just when it has the 1, it will times 0.7 times 175 to those two.
Okay. So what's your opinion for the opponent? We also agree that this one only have energy transfer loss 75%. When you have the more spinners, also have the same number.
I
Huge or not?
I disagree with that because it may be able to change on the it may not be consume 75% because the magnet strength will not be more weak in this experiment.
So how about your opinion? You agree or not?
That I don't agree with.
Okay, the reason is
Because that if there are more spinners, there are more energy loss because of the because the first one will affect that third one.
So you think will be less or higher? Lower or higher?
I think will be lower energy.
Okay.
Can I answer more?
No, you cannot answer it. Okay. Can I have a more question? Okay. Yes. Okay. Yeah. This one. You see, I saw you have the two magnets on the wheel, right?
Yes.
So do you also try to use only one or three? Do you also try the different magnets then?
Because I haven't tried if you use 1 or 3, and because if you just try one, the magnetic force in this magnet will too small and it's very hard to let it spin stably. So I just try 2. And because if you try 3, the magnet will too long, and if you when you spin it, the magnet is easy to fly out.
I see. So, but in your presentation, I didn't see this one. That's why the reason you want to choose 2, but not only 1 or 3. I didn't see it. You were talking right? No.
I don't put it in the
Yeah, because I think the question say the magnet will be force. You will start to rotate only due to the magnetic field. So I think the magnetic field is also very important. You also need to identify the one.
Yeah, I have to do this.
Yeah, and that's why the reason you want to choose 2.
Because
Yeah, you answered already. I got it.
Hello, jurors. I have a short question. No? Okay. Let's go. Okay. Ready. The first we show to the reporter. At 7765. Now the next is show the opponent. Seven, 5, 6, 4, 4. Finally show the reviewer. Seven, 9, 8, 7, 6. Thank you.